So we will learn searching, when searching of a data from a data structure is necessary, very necessary, and that is why there are near about 5 to 7 sorting process according to its efficiency. Okay. Thereafter, there are only two searching process, that is linear search and binary search. And thereafter, another chapter is sorting. There we learn near about 7 different kind of sorting process according to its efficiency. Okay. So after searching and sorting, so searching and sorting, what is the necessary of searching? Searching to find out or fetch out some data from a huge number of database. And sorting is the manage, that is, you can sort the data in a particular manner to find out, to searching process easily identify or sort out or find out one element or the data from the data structure. So this is very necessary, searching and sorting. And thereafter, the job within a table or a database, we need some data or information to insert into that or to delete from that database. So insert and data delete, and sometimes we can modify the data. So this is the job of data structure. So in data structure, we can find out there are different kind of data structure. That means when we insert or this type of job, that is insert, delete, modify, searching, sorting, all these things, that operation will perform in a particular scenario, okay, particular database. So there will be some rule to manage that database, and that rule maintain different kind of data structure. This means if the rule is changed, that means the data structure has been changed. So then according to that rule, we have different kind of data structures like stack, which follow LIFO rule, and queue, which follow FIFO rule. So fast in, fast out, the full form of FIFO is fast in, fast out, and today our topic is stack, that is follow LIFO, that means last in, fast out. So now we just want to draw a stack. So what is the figure of stack? This is the figure of stack. Okay. It looks like a blind lane or single side open or a test tube. You can see here, this is the figure where the only one door is available. So this is your entrance and this is the way you can exit. So the single door, the room have only single door. So if we want one element to insert, so we have to push one element into this put. It look like a pit. Okay. So when we push one element, it will put into this location one by one. The height of this data, if the number of element is increased or insert process is increased, the height of this stack will be increased. So lastly element, suppose we push some first element, that is 5. Okay. And second element, suppose 10. So second element, when we push or insert into this stack, so 10 will come over the 5. So right now, who is the last element? 10 is the last element into this stack. Okay. So now if we want to fetch out or delete one element, that is called pop up. If we want to delete one element, so we need to pop out this 10, this element 10. So to pop out, that is why the operation is called pop. So stack is the data structure which follow the rule LIFO, that is last in first out, and here two operations, that is push. Push is nothing but an insert operation. Why push? Because in this type of diagram, when we insert one element, it looks like we are pushing one element into this block. Okay, and that element will come into the lower position, and who is the lastly inserted, and the new element will be just take the above position of the lastly inserted element. So suppose we want to post 15, so that means 15 will come into this stack and store just above the last element, that is store, and 10 15 will be stored into the next position of 10. Okay, so always the new element will store into the topmost position. Okay, so now one thing, only in stack only one indicator, there is a one indicator which always represent the lastly inserted element. So who is the lastly inserted element? This is the topmost element. So that is why the indicator name is top. The indicator name is top, and it is pointing like that. So right now top is pointing at 50. So now this is look like a stack, and now we represent this stack by array. So we just move this figure into right side, towards the right side. We just bend this figure and lay down into the right side. That means we are take a rotation into right side, just like that. So this will be look like, how many room is there? 6 room. So 6 room, and here is the array, and the name is stk. The name of array is stk, which represent the array as the namely stack. Okay, and this is the position. We know the position of array, the initial position of array is 0, then 1, then 2, then 3, then 4, then 5, and so on. Okay, so if we consider there are six rooms, so 0 to 5, the last room position is 5. Okay, so now if we consider, this is nothing but a max or the size. Okay, so what is the size? So this is size minus 1, basically size minus 1. If the size is 6, the size of array is 6, so that means the array has 6 rooms. If the size of array is 6, so last room position will be size minus 1, because it will start from the 0. Okay, so when the first element 5 will, first element 5 we want to push, so that time the value of stack is 0. So 5 will store into this position, and that means top is at top is at 0th position, basically. If we consider this is the array and this is the look like a original stack, so this is nothing but the position of array 0, this one is 1, this one is 2, this one is 3, this one is 4, and this one is 5, the last one. Understand? So then, so first element, when we store 5 into the stack, so that means 5 will come into lower position. Okay, and it will come into the 0th position, and top represents, because 5 is the topmost or the lastly inserted element. Now when we insert another element 10, so that time we store 10. So 5 is not the topmost right now. So that time top will come into this position. Okay, so top always point the position where lastly inserted element will be stored. Okay, so this is the basic scenario of push operation. So here one thing we have to find out, that is when the stack is full and when the stack is empty. So again we insert another element 15. So 15 will come into store into this position, and same top will represent, that is 15 is the topmost element. Okay, that means what is the value of top right now? The value of top is nothing but the position of that room. So right now the value of top is 2. So that means the 15, the lastly element node, the lastly element value, lastly inserted value, that is stored into the position 2. So top always indicate the position where the lastly inserted element has been stored. Okay. So now if we want to delete one element or pop out, that means pop operation. So stack has two operations, that is push operation and another is pop operation. So push is nothing but insert and pop is nothing but a delete. Clear to all of you? Okay. So what is the, so lastly we already know what is the job of, what is the purpose of push operation. So every time when we push one element, so that means top will be increment its value, and that particular position we will insert the new value. So what is the job? First we increment the value of top because the operation is insert. If we can insert, this is the logic. If we can insert, so that time top will be increment its value. So top will go to the next room, and the next room the new element will be inserted, or we can say the new element will be inserted at top position. So what is the position of top? Top increment its value. So value of top was 2. Right now value of top is 3. So at STK array, if the name of the array is STK, so STK array at 3 position we will insert the new element. Clear to all of you? Okay. Now delete operation. So if we want to delete, so delete does not mean that we will erase the value. Okay, we just ignore the value. So before to discuss the pop or the delete operation, first of all we have to display the or display function. That means no, whatever the changes when we insert one element, that is the change. That means the scenario will be changed. When we delete or pop operation is performed, so again whatever the scenario lastly was, that will be changed. So that means what is the change that is affected by display function. So another job is or function is display. So in display, using display, we can find out what is the effect of lastly performed operation. Okay. So now if we want to display this stack, so we will print all the element is already stored into the stack or this STK array. So we know the very first position of array is 0th position. Okay. Okay. So that means if the stack is not empty, so we will print all the element that is available within the stack, and where to start, where the end. We have to find out the array, this STK array or stack, where is the starting position and where is the end position. So starting position in array is the 0 and end position is the top position, because top indicates where is the lastly inserted element. Okay, so we have to print from 0 to top positions value. Clear to all of you? So this is